Okay, we're talking about setting up a CAN bus using Arduino and Raspberry Pi systems. CAN bus was originally developed as a network for automotive applications, but eventually has been used for a lot of other industrial and home automation purposes. You can see here on this breadboard rail, I've actually set up a CAN bus on it. Got termination on both ends and two nodes hooked up to two Arduinos right here. Later on, we'll come back and add a Raspberry Pi. This could be any twisted pair network, I think up to at least a kilometer in length in some applications, depending on your speed. Here I've got two Arduino Duros and a shield from SparkFun that was actually designed by SK Pang. And it has the microchip 2515 CAN controller and the 2551 transceiver, which are real common in these applications. It's got a DB9 connector so you can hook up to a car easy. Direct jumper connectors, which is what we're using now. It's also got an SD card, a link to a GPS, a little joystick for control, and an optional serial LCD connector. Really handy shield for this sort of stuff. On this one you can see I've actually got the GPS hooked up and a serial connection back to my computer, which is also what's powering everything right now. So if we go over here and we'll start up the serial monitor, you can actually see the top one. It's waiting for input. Started up the bus and now it's receiving messages and GPS messages. I have the other Arduino broadcasting the number of messages it sends every second or so, and you can see that incrementing in the ASCII data of the CAN bus. So that's pretty much it for those two. It's a very simple setup. I have learned even on a small network like this, if you don't have termination, you will often not get any data, so you need to have that there. On a small network like this, the resistor values don't matter too much. I think these are 100 ohms if I remember correctly. 120 is the standard, and you'll need larger ones if you go to a longer network, 150 if you're talking about many meters. And next we'll do the Raspberry Pi.